the law of conservation of momentum. When two bodies of masses m1 and m2 collide, the total momentum before the impact is equal to the total momentum after the impact. So, if you have two masses, wait, m1 and m2, so collide sila, it says that total momentum before the impact is equal to the total momentum after the impact. And take note, the formula for momentum is P as momentum is equal to mv, mass times velocity. So, ang total momentum before the impact is simply mass 1 times the initial velocity of mass 1. Okay, u is equal to the initial velocity. Okay, plus m2 times the initial velocity of mass 2 equal to total momentum after the impact, that is mass 1 times the final velocity of mass 1. So, v is the final velocity. Okay, plus m2 times v2. Okay, so mauni mo hang formula for the law of conservation of momentum. Now, related sa kanina topic is katong types of collisions. Okay, now you have two types of collisions. You have the elastic collision and the inelastic collision. Now, ang elastic collision, it's when ang duha ka bodies, if mag-collide sila, after the collision kay mo separate sila. Okay, again, when two bodies collide, after mo separate sila. One ang elastic collision. Now, if mag-solve mo problems sa elastic collision, ang iyong gamiton na formula is same gihapon kana. Tapos, ang second type is the inelastic collision. Sa inelastic collision, it's when if two bodies collide, mustick sila together after collision. So, mustick sila together after collision. Okay, so, for example, naakay box, tas naakay object na imuhang ilabay sa box. Then, after nimo siya ilabay, mustick siya diri sa box. Then, that's inelastic collision. Okay, inelastic collision. Now, the formula for inelastic collision is, let's say this is mass 1, this is mass 2. So, m1, u1, plus m2, u2, where ang u is the initial velocity, is equal to, after collision, diba, mag-stick sila together. So, consider sila as one object this time. So, simply add the masses of the two. So, that is m1 plus m2. Again, tungod kay nag-stick sila. Okay? Then, they have one final velocity, vf. So, if inelastic collision ang problem, mo na yung i-follow na formula. Okay? A 4-gram bullet is fired from a 5-kilogram gun with a speed of 600 meters per second. What is the speed of the recoil of gun? So, the speed of the recoil of gun. So, let's say mo na imuhang gun, then inside na imuhang bullet. Now, if i-fire nimo ang bullet, di ba na kay mag-apply kag force padulong diri para malagpot si bullet. Now, kanang recoil sa gun, mo na siya tong backward movement sa imuhang gun. Again the backward movement sa imuhang gun. So, mo ni siya that this is due to the third law of motion. Third law of motion, the action and reaction. Okay? Okay. Anyway, ang ginapangita is ang speed sa recoil sa gun. So, kaning speed pa backward. Now, ang given na to is mass 1, let's say mo na ang bullet, that is 4 grams. 4 grams, convert that to kilogram, you have 4 times 10 raised to negative 3 kilogram. Initially, yung velocity is 0. Okay, 0 is because ang gun and ang bullet initially is stationary. 0 siya. Mass 2 is the 5 kilogram gun. Initial velocity of the gun is also 0. Now, the final velocity of the bullet is 600 meters per second. Okay? Again, the bullet is fired with a speed of 600 meters per second. Now, ang final velocity sa gun, mao na to siya ang atong ginapangita na speed, which is also the speed sa recoil sa gun. Now, applying the concept of law of conservation of momentum, we have m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So, substituting, you have 0 ni, 0 ni. It's because the initial velocities are also 0. So, 0 is equal to, mass 1 is 4 times 10 raised to negative 3. Velocity 1 is 600 meters per second. Plus, mass 2 is 5. Velocity 2 is, v2 is the unknown. So, one equation, one unknown, solving for v2, you get negative 0.48 meters per second. Okay, answer. Take note, negative sign meaning definitely pa backward yun ang movement. Okay. A block of mass capital M is moving to the left at a speed of v in a straight line. How fast would a bullet of mass small letter m need to travel to the right to stop the block, assuming that the bullet became embedded inside? So, before collision, you have a block of mass capital M that is moving to the left at the speed of capital V. Then, naakay bullet with a mass of small letter m moving to the right with, let's say, a velocity of small letter u. Now, after the collision, ang bullet daw became embedded inside. So, after collision, mo na ni siyang scenario, mo na ni ang bullet. Okay ha? Take note, embedded inside. So, this is inelastic collision. Embedded inside, inelastic collision. So, ang ginapangita sa problem is, how fast would a bullet of mass m? So, ang velocity sa mass m, such that ma-stop niya ang block after the collision. Okay? So, applying the law of conservation of momentum, you have total momentum before the impact is equal to the total momentum after the impact. So, you have mu plus capital M. Then, take note, negative v. This is because ang imuhang block is moving to the left. Okay? Moving to the left. So, that is negative x direction. So, negative v equal to, since nag-stick sila together, and since inelastic collision siya, you add the two masses together after the collision. So, that is m plus capital M. Then, the final velocity. Then, ang value sa final velocity is 0. It's because nag-stop daw ang block. Okay? So, final velocity is 0. So, kanina, 0 na siya. So, ang mabilin is mu plus m negative v is equal to 0. Okay? Ang ginapangita sa problem is ang speed sa bullet, kaning u. So, solving for u, you get u is equal to mv over m. So, answer. 17-gram mass is moving at 30 centimeters per second, while a mass of 4 grams is moving in opposite direction at 50 centimeters per second. They collide head-on, stick together. What is the velocity after the collision? So, you have mass 1 that is 17 grams. Take note, ang grams, convert that to kilograms. So, you have 17 times 10 raised to negative 3 kilograms. And its initial velocity is 30 centimeters per second. So, ang centimeters, convert that to meters. So, you have 30 times 10 raised to negative 2 meters per second. Mass 2 is 4 grams. So, 4 times 10 raised to negative 3 kilograms. Its velocity is 50 centimeters. So, that is 50 times 10 raised to negative 2 meters per second. And take note, it's moving in the opposite direction. Okay? Opposite direction. So, ito ay siyang i-negative 3. Okay? Now, they collide head-on, stick together. So, this is a, wait, okay, naglag. So, they collide head-on, stick together. So, this is, since nag-stick together sila, that's in elastic collision. So, what is the velocity after the collision? So, applying the formula of law of conservation of momentum, you have, wait, you have m1u1 plus m2u2 is equal to, since nag-stick together sila, you add both masses, you have m1 plus m2 is equals to vf. Ang ginapangita is ang velocity after collision. So, substituting what you have 17 times 10 raised to negative 3. U2 is 30 times 10 raised to negative 2. M2 is 4 times 10 raised to negative 3 times negative 50 times 10 raised to negative 2. Again, negative because it is moving in the opposite direction. Okay, so equal to, you add both masses, 17 times 10 raised to negative 3 plus 4 times 10 raised to negative 3 VF. So, shift solve, VF is equal to 0.1476 meters per second. Okay, answer. Number 4. A 10-gram block slides with a velocity of 20 centimeters on a smooth level surface and makes a head-on collision with a 30-gram block moving in the opposite direction with a velocity of 10 centimeters per second. If the collision is perfectly elastic, what is the velocity of the 30-gram block after the collision? Okay, so you have mass 1 is equal to 10 grams, so convert that to kilograms, 10 times 10 raised to negative 3 kilograms. Yung velocity, initial velocity is 20 times 10 raised to negative 2 meters per second. Na kay mass 2, that's 30 times 10 raised to negative 3 kilograms. Velocity, initial velocity is 10 times 10 raised to negative 2 meters per second. Now, the collision is perfectly elastic. So, meaning, after collision, separate sila. Now, what is the velocity daw of the 30-gram block after the collision? So, unsa daw ang final velocity ani niya? Okay, so applying law of conservation of momentum, you have m1u1 plus m2u2 is equal to, since perfectly elastic siya, dili sila mo stick together, so separate ang ilahang final velocities. You have m1 v1 plus m2 v2. Take note, ang letter u mo ng initial velocity, letter v mo ng final velocity. Now, sige, so substituting, you have 10 times 10 raised to negative 3 times 20 times 10 raised to negative 2 plus 30 times 10 raised to negative 3 times negative. Okay, negative because kanina block is moving in the opposite direction. So, negative 10 times 10 raised to negative 2 is equal to 10 times 10 raised to negative 3 times the final velocity of mass 1 plus 30 times 10 raised to negative 3 times the final velocity of mass 2. Okay, so equation number 1. Now, take note, you have one equation but two unknowns. So, need nimo og another equation to solve the problem. Now, ana ang problem that the collision is perfectly elastic. Now, if perfectly elastic ta, iyahang coefficient of restitution is equal to 1. Okay, kaniha, kanang letter E is the coefficient of restitution. Restitution. If perfectly elastic ka, your coefficient of restitution is equal to 1. If inelastic ka, that's equal to 0. Now, if imuhang makuha na coefficient of restitution is from 0 to 1, or in between those two, in between 0 to 1, kana is partially inelastic. Unsa nang partially inelastic? Ang partially inelastic if ang duha ka objects mo collide, pero after collision mo stick sila kadyot, pero eventually mo separate way sila. So mo nang partially inelastic ka. Mo stick kadyot, then mo separate way. Okay, so partially inelastic. So kaning letter E, or coefficient of restitution, you have a formula for that. That is E is equal to V2 minus V1 over U1 minus U2. Okay? Na for me, akong definition for coefficient of restitution is kung unsa ka bouncy ang isa ka object. Pero naapay mas scientific way of explaining that. Pero kato lang akong explanation na ha, kung unsa ka bouncy or unsa ka sticky ang isa ka object. Mo nang pag elastic ka, okay, imuhang restitution is equal to 1 kay bouncy kay ka, meaning mo separate yun ka, mo nang elastic ka. Pag imuhang coefficient of restitution is equal to 0, so dili ka bouncy, sticky ka, mo nang inelastic ka, mo stick yun ka. Kani 0 to 1, dili pug ka super bouncy, dili pug ka super sticky, konti lang, mo nang partially inelastic ka. So again, napay mas scientific explanation sa pag-explain ha. Mao lang to ako ang definition sa coefficient of restitution. So anyway, solving for the coefficient of restitution to solve the problem. Okay, so coefficient of restitution is 1 is equal to V2 minus V1 over U1. Okay, na ate U1, di ba? U1 is equal to 20. Okay, so 20 times 10 raised to negative 2 minus U2 is equal to negative 10 kay opposite direction ka. So that's negative 10 times 10 raised to negative 2. So you have 0.3 is equal to V2 minus V1. So rearranging the equation, you have V1 is equal to V2 minus 0.3. Equation number 2. So insert equation number 2 in equation number 1. You have so simplify nimo ni kanana part, you get negative 1 times 10 raised to negative 3 equal to 10 times 10 raised to negative 3 times V2 minus 0.3 plus 30 times 10 raised to negative 3 V2. Okay, so one equation, one unknown. You can solve the value of V2. You have 0.05 meters per second. Answer. A 7,500 truck traveling at 5 meters per second east collides with a 1,500 kilogram car moving at 20 meters per second in the direction of 30 degrees south of west. After collision, the two vehicles remain tangled together. With what speed and in what direction does the wreckage begin to move? Okay, so you have mass 1 is equal to 7,500 kilograms. Yung initial velocity is 5 meters per second. Mass 2, you have a 1,500 kilogram car. Okay, yung initial velocity is 20 meters per second. So, kung i-illustrate nimo na siya, okay, before collision, ang imuhang truck is moving to the east. Okay, so that is mass 1 moving to the east. Then imuhang car is moving in a direction of 30 degrees south of west. So NEWS 30 degrees south of west, mao ni siya imuhang 30 degrees. Okay, so kung illustrate na siya, ara siya kinana. Okay, mao na si 30 degrees. Mao ni siya si mass 2. Okay? Now, question is, after collision, with what speed and what direction does the wreckage begin to move? So, kanina problem, since remain tangled together sila, it's an inelastic collision. Okay? So, solving for the problem using the concept of law of conservation of momentum, you have M1 U1 plus M2 U2 is equal to, since inelastic na siya, so i-add nimo ang duha ka mass, M1 plus M2 times the final velocity. Okay, so i-substitute, you have 7,000. Okay, Now, take note na kanina problem, di ba atong previous problems ang naalang man sa x-axis ang ato ang direction. So this time, kung iyong tanawon na natay mga degrees, so involved na po diri this time ang y-axis. So basta inani gani pag nanay mga degrees ang problem, inyuhang pag-solve is inyuhang i-separate ang pag-solve tong mga x component niya o yung y component. So this time sa x component sa ta. So i-consider sa nato is katong sa x-axis. So now si M1 since moving along x-axis siya, pais man siya. So imo siyang ibutang diri, so 7,500 times 5 plus si M2 yung mass is 1,500 pero imong i-consider na velocity niya is kato x component lang sa iyang velocity which is kana. Okay? So kani si Vx niya mo ni si Vy niya. Ay sorry. Basta kana yung x ug y component. So imong isulat is 1,500 times 20, okay, cosine 30 para sa x component lang equal to i-add nimo ang duha ka mass, pila man na, pila ba, wait, 7,500 plus 1,500, okay, that's 9,000, okay, tapos Vx. Okay, so isolve nimo si Vx. Ang x component sa final velocity imuhang makuha is 1.2799 or shift store A na lang. Okay, shift store A sa ka. Okay, after sa x-axis, sa y-axis na pug ka. So, check nimo ang mass 1. Kung imuhang tan-awon, imuhang mass 1 wala siya y component sa iyang velocity kay iyang direction pa east lang. So 0 na siya. Plus si mass 2, so i-check nimo na siya y component siyang velocity. So that's 1,500 times 20. Okay? This time sin 30 na ka. Okay? Para sa y component lang. So wait. Sin 30 is equal to 9,000 Vy. So, ang y component sa mong final velocity is negative 1.667 or shift store B. So, to get the final velocity, ang magnitude sa mong final velocity, taking the square root of, naglag, wait. So, Vx squared plus Vy squared na lang. So, ang answer ana is 2.1 meters per second. Okay mo na imong final velocity. Now, para makuha ang direction, since nangayo ang problem o direction sa wreckage, kung kana ang direction sa imuhang wreckage, kinakuha ana niya, diba, is ang theta. So, kung kani si y component, mao ni si x component, therefore, tan theta is equals to Vy over Vx. Okay, or B, shift store B over shift store A. Okay? So, solving for theta, you get negative 53 degrees. Ang meaning anang negative is if kamo ni mong x ug y, di ba, negative padra ka. So, mo ni mo hang 53 degrees. So, imong direction is 53 degrees, okay, south of east. Okay, south of east. Okay, answer. Two objects with a mass MA and MB collide in a perfectly inelastic collision. If MA is equal to 3MB over 2 and velocities VA and VB are 5I plus 3J and negative I plus 4J respectively, what is the kinetic energy after collision if MA is equal to 1,200? Okay? So, therefore, si MB, if imuhang i-solve, equal to 800. Si velocities VA is 5I plus 3J. And si VB is negative I plus 4J. Yung ipangita is the kinetic energy after collision. Take note, the formula for kinetic energy is 1/2 mv squared after collision. So, since inelastic ka, perfectly inelastic ka, mo stick sila together, so imong mass dire i-add lang nimo sa MA o sa MB. Kaning velocity dire, mo na siya ang final velocity dapat after sa collision. So, need nimo na siya i-solve karon. Now, formula is MA VA plus MB VB is equal to MA plus MB times the final velocity. So, substituting what you have 1,200 times 5i plus 3j plus 800 negative I plus 4j is equal to 2,000 VF. Okay, so take note na akay mga I and J components. So, same sa problem ganina, if atong gibuhat is gi-separate nato og solve ang X and Y components, this time, imuha pong i-separate og solve ang iyang I components and J components. So, first, I components ata. Okay, so, to solve for the I component of your final velocity, ano ba? VF, ano na lang. Okay? So, 1,200 times 5 plus 800 kana times negative I, negative 1 divided by 2,000. Okay? Answer is 2.6i. Okay? Now, the J component na punta. So, VFJ. So, you have 1,000 times ang J component, 3 plus 8,000 times 4 divided by 2,000. You have 3.4J. Okay? So, the final velocity is 26i plus 3.4j. So, taking the magnitude of that, kuha ilang magnitude, that is 2.6 squared plus 3.4 squared equal to 4.28. So, solving for the kinetic energy after the collision, you have kinetic energy is equal to 1/2 mv squared. So, that is 1/2 times 2,000 times final velocity is 4.28 squared. Answer is 18.3 kilojoules. Answer. Ball 1 moves towards ball 2 whose mass is twice that of ball 1, which is initially at rest. After their impact, the object locks together and moves with what fraction of ball 1's initial kinetic energy? So, you have ball 1 that moves towards ball 2. Okay, so we have mass 1, then initial velocity ni ball 1, then si mass 2, which is also twice, mass is twice that of ball 1, so 2m1. Yung initial velocity is 0 since initially at rest siya. Now, after the impact, the object locks together. So, that is inelastic collision. Okay, inelastic since nag-stick together ang duha ka object after collision. Now, with what fraction, okay, after their impact, the object locks together and move with what fraction of ball 1's initial kinetic energy? Okay, so ang question is, ang iyang pangutana is, if, let's say for example lang ha, mauni siya si kinetic energy or initial kinetic energy ni ball 1. So, this is the kinetic energy before the collision. Take note, kinetic energy before collision is greater than kinetic energy after collision. Okay? Then, after collision, ang kinetic energy ni ball 1 na iyang nagamit is, let's say, kanina part. Mao na si kinetic energy after collision ni ball 1. Ang question is, ang gusto niya makita, if kani si after collision, pila daw ni siya ka-portion sa initial kinetic energy ni ball 1. Again ha, ang gusto na to makuha sa problem is, if kani si kinetic energy after collision, pila daw ni siya ka part or pila daw ni siya ka portion sa initial kinetic energy ni ball 1. So to get that, to get the fraction of that, just divide the kinetic energy after collision by the kinetic energy before the collision. Okay? Take note, the formula of kinetic energy is 1/2 mv squared. So therefore, kailangan na to makuha ang kinetic energy, kailangan na to makuha ang final velocity after collision to solve for the kinetic energy after collision. Okay? So, you have m1 u1 plus m2 u2 is equal to, i-add nimo ang duha ka mass since inelastic ni, so that is m1 plus m2 vf. Okay, kani is ma-cancel since initial velocity ni ball 2 is 0. So simplifying, you have m1 u1 is equal to, kani is 3mi vf. Therefore, final velocity is m1 u1 over 3m1. That is, cancel si m1, you have 1/3 u1. Mao na si final velocity after the collision. So, okay, so solving for the kinetic energy before collision, you have 1/2 mass 1 times u1 squared. Okay? Then the kinetic energy of ball 1 after the collision, that is 1/2. And then nag-stick together sila, so that is 3m1 na. Then yung final velocity is 1/3 u1 squared. Okay. Then again, i-divide lang nimo si KE after collision and KE before collision. So you have 1/2 3m1 times 1/3 u1 squared divided by 1/2 m1 u1 squared. So, si cancel ni, cancel. Then, i-simplify siya. Ang makuha ni mo na answer is 1/3. Okay, mag-cancel lang na siya. So, 3 times 1/3 squared, that is 1/3. Okay, so this is the final answer. Now, if, for example, wala li mo naisipan itong mag-divide or malibog ka, pwede man ka mag-assume of value. Okay? So, erase na ako ni ha. Basta, anyway, erase na ako ni. So, for example, malibog ka mag-cancel, pwede lang ka mag-assume. Diba na naman kayo na na formula. Ang wala lang ta, isang value ni m1, u1, m1, u1. So, assume na lang ka. So, let's say, let m1 and u1 equal to 1. So, therefore, kinetic energy before collision is just 1/2 times 1 times 1 squared. So, pila man na? 1/2. Kinetic energy after collision, that is 1/2 times 3 times 1 times 1/3 1/3 squared. So, pila na siya? 1/6. So, dito nakuha ang fraction. So, to get the fraction, again, i-divide lang nimo si KE after and KE before. So, that is 1/6 divided by 1/2. You get 1/3. Okay? Number 8. Okay, number 8. A 0.10 kilogram object moving initially with a velocity of 0.2 meters per second makes an elastic head-on collision with a 0.15 object initially at rest. What percentage of the original kinetic energy is retained by the 0.10 kilogram object? Sige. So, you have mass 1 equal to 0.10. Initially moving with a velocity of 0.2 meters per second. Na kay mass 2 with 0.15 kilogram mass that is initially at rest. Okay, elastic head-on collision. Elastic. So, meaning nag-separate siya. Okay? Since elastic siya, yung coefficient of restitution is equal to 1. Now, question is, what percentage of the original kinetic energy is retained by the 0.10 kilogram object? So, mura siya same lang ganina sa problem. na if, for example, mao ni siya ang original kinetic energy ni mass 1, okay? Then, after the collision, let's see, ang na-retain is kani, after the collision, so pila daw ni siya ka-percentage sa original na kinetic energy. So, mara siya same lang yapon ganina. So, sige, so solving for the final velocities, so you have m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So, cancel ni siya. Okay, 0 ang iyang initial. So, you have 0.10 times 0.2. Oops, naglag. Wait. 0.2. Okay. Is equal to 0.10 v1 plus 0.15 v2. So, you have one equation, two unknowns. So, kailangan pa ni mo another equation. Ganina, di ba, naggamit og coefficient of restitution tong problem ganina. So, same lang po diri since we know na elastic collision ni siya. So, we also know that the coefficient of restitution is equal to 1 since elastic siya. So, again, the formula for the coefficient of restitution is E is equal to V2 minus V1 over U1 minus U2. Okay? Equal to 1. So, solving for that, solving for this equation, you have 1 is equal to V2 minus V1 all over 0.2 minus 0. So, you have kalat. So, you have 0.2 is equal to V2 minus V1. So, therefore, V2 is equal to 0.2 plus V1. That's the equation number 2. And then, kani si equation number 1. So, substitute equation number 2 to equation number 1. You have 0.10 times 0.2 is equal to 0.10 V1 plus 0.15 0.2 plus V1. Okay, so one equation, one unknown. You can solve for V1. That is equal to negative 0.04 meters per second. Okay, this is the final velocity of mass 1. Okay, na atong kuhaon is okay. Kuhaon na to ang kinetic energy before collision and after collision ni mass 1. So, kinetic energy before collision is 1/2. Mass 1 is 0.10. Ang initial velocity is 0.20 squared. So, this is pila man eh. This is wait, calculate. 1/2. Wait lang, sorry ha. 0.10, 0.2 squared. Okay. 2 times 10 raised to negative 3 joules. Okay? Then, ang kinetic energy after collision, that is 1/2. Mass niya, 0.10. Iyang final velocity after collision, pila to? That is negative 0.04 squared. So, imuhang makuha is 8 times 10 raised to negative 5 joules. Okay, so to solve for the question is what percentage of the original kinetic energy is retained? So, to solve for the percentage, so that is KE after collision divided by KE before collision times 100%, you get 4%.